Am I right? First of all, you have to observe one living system. Example, human brain I gave here. So you have to observe one living system. Why living system? Because we have been discussing about the intelligence behavior, which you generally find in nature. Not only human being, but also other animals, other species also. They exhibit intelligent behavior. That's why if you observe them, uh, then you can really understand what it is in their conditions. Okay. Then, so once you consider the living system, actually your problem will start here. That is problem situation. That means this you are choosing. You are choosing. You have a problem. So when you have a problem, you want to solve it. So for that, you need to understand what are the different conditions in which you need to solve the problem, and what are the different conditions you have to satisfy to come up with the solution. That time, what you do is you are going to choose, is there any similar situation in the nature? So if there is a similar situation in the nature, first of all, you are going to understand that. Okay. So when you understand that, then you can actually comparatively understand your situation also, your the system's behavior also. So this way, living systems, human brain, for example, I put there. So here your problem, you are going to build one kind of solution or a machine or some kind of artificial system you are going to build here. But in this artificial system, left side, in this artificial system, you want to incorporate the intelligence that you are going to observe in the nature. So once you take the metaphor, or once you actually choose a inspiration, then you are going to build a qualitative model of adaptive behavior. That means what you are going to understand here, already you know that you are going to understand how the functions are varying with respect to time and conditions. That is the way you are going to understand the behavior of any system. Hope you will agree with me. Hope you didn't forget. Okay. So you are going to understand different functionalities, how they are changing with respect to time and different conditions. Okay. So when you observe that, you are going to build a qualitative model of adaptive behavior. Adaptive behavior. So adaptivity, already we discussed a lot about it from the general definition onwards, and the general definition of intelligence onwards. So qualitative model means here you are not going to take any numbers. You are qualitatively going to say what functions, what are the different functions coming into picture with respect to time. Those are useful for you. So you are going to work out what are the different functions uh, changing with respect to time and with respect to external conditions or with respect to environment. So after considering them, you are going to make a model. That means with these functions, which are varying with respect to time, I can actually make a I can actually make a model, right? So now you can actually compare analogy between these two. So can you bring this kind of functionalities which you are seeing in the nature in your system? Okay. If you are able to bring by using electronics, by using software, or by using anything mechanical methods, can you bring these functionalities which will change with respect to time and conditions in your system? In that case, you are actually mimicking the qualitative behavior. The same way, here, rigorous formulation. Rigorous formulation means what you generally do, you are going to make here qualitatively, you understood. Now, can you bring these functions into mathematical form? Why mathematical form? Generally, functions are being because function is nothing but an operation varying with respect to time or with respect to any other parameter. Hope in mathematics you know about functions. Okay, so here functions are varied. So if you can formulate the function with a mathematical, any standard functions, then you can understand the behavior also with respect to mathematics. Okay, so that's why if you remember behaviors or anything, what is the behavior? Linear behavior, parabolic behavior. Okay, so elliptical. So the behaviors are can be explained with respect to mathematical functions also. So function means, hope you know already. So function is nothing but the combination of few variables, which depends on few variables. Okay, so if you can explain the functions or the behavior with respect to some mathematical function, then that will give you the rigorous formulation of a mathematical modeling. Okay, so this I kept in red color because at this point of time, I don't think you can do these things. Okay, but you please try to understand this. If you listen to complete video, you will understand that. Because why we use mathematical function? Because we want to explain behavior as a pattern. Line is a pattern, parabola is a pattern, suppose zigzag structure is a pattern. So you are explaining behavior with respect to a pattern. That pattern can be explained with respect to a mathematical function. Okay, how complex it is, it's okay. Okay, mathematical function. Once you assign the mathematical function, then actually mathematical operations will tell you how you are going to build the mathematical system or mathematical model that will lead you standard scientific model. Okay, from taking inspiration suitable for your problem to building a scientific model that actually suitable to build a intelligence in your artificial system. This is what you are doing. Okay, so please, if you didn't go through, please go through it. That is very important. And so because if you want to build the intelligences, you know how to especially try to understand this one, how to explain something qualitative behavior. So qualitative behavior, you should be able to tell that maybe a tree, dog, whatever you see, whatever you observe outside, can you explain the qualitative behavior? So that means functions varying with respect to time and external conditions. If you can do that, second step is over. Okay. So those functional changes or behaviors, can you assign some mathematical formulation? That means, can you explain this behavioral pattern with respect to some mathematical function? Then in that case, you are actually converting this qualitative thing into a mathematical thing. So this mathematical model, once you complete, you have a standard scientific model that will actually create the intelligence in this kind of systems. Okay, please remember, you can read this Decision and Control by Stafford Beer, okay, 1966 paper. If you read this, you will understand. Okay, so I just repeated that as a continuation to last class. So this we will do later. I'm changing the slide. Please let me know if your slide is changing later. Assignment we'll do later. Okay, is the slide changed? Now I kept a living systems theory, bio-inspired intelligent behavior.
The same side.
Yeah, it will change. So please let me know if the slide changes.
No, sir, it's still the same.
Now, so bio-inspired intelligent behavior, living systems theory. That is what my slide is. You please let me know once you see that. Now I again reshare it.
Sir, your screen isn't visible.
No, I just stopped presenting, again represented. You please wait.
Okay.
So now it's visible.
Now it's coming up. Okay. Yeah. So this is what we are going to discuss. Okay, sir, you are saying that we can design the intelligence of any system. We can design the intelligence uh, of my system by taking inspiration from the nature or by observing the behavior in any other systems. Then what we need to observe in that particular uh, how really we can understand them and rebuild them. Here, not only understanding, we have to understand the process behind this behavior, process behind this changing in functionalities. What is really triggering this functional changes? What is really triggering these behaviors? That is what you need to understand. Am I right? So that is where we will actually encounter many natural systems with important uh, the phenomenon like self-evolve, self-improve, and also self-configuration, self-organization, self-optimization, which you call them as self-aware. Self-aware. Okay. So here, these entities, very important phenomena you observe in nature, which are related to self-evolution. Second, self-improvement. Third, self-aware. Okay. So I will just try to make them in red color. Wait. So I'll just make them in red color. Okay. So these are the two things. And after this, so please observe the red color things. What you observe in nature, you tell me whether that is true or not. Self-evolve. Second, self-improve. Third is self-aware. These three characteristics are there in nature or not. Because as per the living systems theory, if you want to build a intelligence behavior, kindly observe these things in any system to understand what is really happening inside that system. Okay, that is what this theory says. I'm repeating. If you want to build the bio-inspired intelligence behavior in any system, the living systems theory suggests that please observe self-evolution, self-improvement, and self-aware characteristics in any system in the nature. If you are able to observe that, you can really understand what are the internal processes going on in these intelligent systems. Once you understand these things, you will also come to know how to build the intelligence. Okay. So now please tell me, I'm changing the slide. What is mean by self-evolution? Can somebody tell me? Do you have any idea? General question. I don't want standard definitions or something. General definition.
Knowing our
Self-evolve.
advantages and disadvantages.
Self-evolve. Self-evolution. Any idea? Self-evolution.
Sir, lava in the earth core.
Sorry?
Sir, lava in earth core. Lava heat.
I'm not getting your point. Please clearly tell. Don't murmur.
Sir, lava layer in earth core.
Lava layer in earth core. So what is mean by evolution there? Self-evolution. I'm asking about self-evolution. What is mean by that?
Sir, the heat and that the plasma is developed on its own.
No, is it the behavior of the earth? Or is it the behavior of lava? Any other thing? What is mean by self-evolution? Self-evolution and self-improving. Please remember, they are nearly correlated. Suppose you don't know how to cook chapati. Let's assume. When you don't know how to cook one particular dish or chapati, because everybody know about it, I'm taking that example. The first day, the way you make will be one kind. The second day, if you do the same task, it will be slightly different. The third day, if you do that same thing, same task, it will be again different. The seventh or eighth day, if you do the same thing, it will be different. Why? Is my example clearly? Is my question clear? Suppose you don't know to cook or make chapati. In that case, you are starting and the first day, when you start that, the way you make it will be of one kind. Second day it will change. Third day it will change. Fourth day it will change. Fifth day also it will change. Finally, when I see at the eighth day, it will definitely not be like the first day. Am I right? So what happened in this process? Any idea? Is something really happening? If it is happening, what is that? Anybody? So that is called learning. Okay, please remember that is called learning. So evolution is always about learning and understanding the systems or the task. So once you understand something, slowly you are changing the way you do the things. Slowly you are changing the way you perform the task. In the eighth day, you are going to get the perfection. That means there is a clear evolution from day 1 of making chapati to day 8 making chapati. It is clearly related to your intelligence. If somebody doing the way same way he is doing on the first day, same way he is doing on the 10th day, then he is not learning anything. There is no evolution in his intelligence, or there is no evolution in that system. So learning process will make you to evolve from one state of intelligence to another state of intelligence. In this particular case, after 1 week or 8 days, you are going to get the perfection. Okay, that means your intelligence is evolved from unknown to known. Okay, so that is what evolution means, changing the state of intelligence from one to another. Second, the self improvement, same thing. There is no much difference. There is no much difference. You will always improve the functionalities or way you are going to execute the functionalities to achieve some task. Okay, that is also part of intelligence. These are the things you need to observe in the nature to understand the internal process of intelligence. I'm talking about internal process of intelligence. It is not the externally what you observe. You need to understand the internal process of intelligence. The third one is, hope the slide is visible. The third one is self-aware. The self-aware is always the very important thing, where self-configuration, self-organization, self-optimization properties will come under. So what is meant by this self-aware? Do you know at least about this? Are you self-aware? How do you say that you are self-aware? And what it is mean by? Anybody? Anybody? So self-awareness is nothing but system continuously monitoring what are the changes coming in its structure, in its form, in its functionalities, or in its behavior. Continuously monitoring what are the changes taking place in the system. If the changes are taking place drastically, what happened to the system? What is the problem to the system? If the changes are happening drastically. Any idea? You know, already we discussed.
Unstability, I guess.
Yes, it will become unstable. That means it will go away from the equilibrium. Very good. If it is going away from the equilibrium, it cannot survive. Am I right? So self-awareness, that means self-configuration. That means it has to adjust its structure according to the environment, according to the situation, according to the condition. Self-organization, how to maintain the structure. how to maintain the form, then optimization, how to maintain it in a suitable fashion, where your equilibrium is always maintained. That is called self-aware. Self-aware is like it's a continuous monitoring of system on its own about its structure, about its form, about its functionality, to avoid the instability or to avoid the instability. Who is monitoring whom? System is monitoring on its own. What it is monitoring? It is monitoring the structure. It is monitoring the form. It is monitoring the functionalities. Okay. So it is continuously monitoring these things so that it will try to keep it will try to be in stable state or equilibrium state all the time. So that is what happens, self-awareness. So self-evolve. So the way to achieve the perfection, self-improve, same way, and self-aware. So whatever the system is doing, system must have the control over what is happening in it. That must be there. Self-awareness. So what is happening in its configuration? What is happening around is important. Yes. What is happening within is also most important. Okay. Then only it can maintain the equilibrium. So this self-awareness also you observe in the nature. Okay. So now you will get many questions. Sir, you are teaching these things. You are saying self-evolve, self-improve, self-aware, these all things, but how to build them? Because eventually I want to know how to build these properties or the characteristics in my system. Okay. So in order to know that, you must know how these are occurring. So those 4 questions are very important to answer. What are the 4 questions? How to design a basic system components in which decisions are distributed and not fully controlled by single component. That means if you build a system that is not centrally controlled, so individual parts, that is subsystems also can organize or can configure themselves. So that kind of systems you need to build. Second is how to design strategies that allow system to adapt to the environment changes. So now all different parts can decide on their own. So how they are together going to face the external conditions. Okay. So that is the second one. What are the dynamic rules that drive the system to expected behavior? That is the question, the most important for you to understand what is the intelligence. Okay. So what is the basis for all these properties to occur? Self-evolve, self-improvement, self-awareness. How these are all happening in the systems? How these are all happening in the biological system? So you are also biological system. So these are all happening in you also. The third question, what are the dynamic rules that drive the system to the expected behavior? What are those rules you need to define? Okay. So what are the techniques and tools to realize them? That's okay. So the third question, if you ask me, my answer is okay. You need to observe the feedback loops. Please remember feedback loops. The feedback loops are the core design elements and should be made explicit in modeling, design, implementation, and validation approaches. So this excuse me. Just a minute, I'll get back to you. Okay. So the dynamic principles, what you need to observe in any system are feedback loops. What are these feedback loops? Computer science people will understand easily, and others also who know some programming knowledge. You will understand easily. Okay? Wherever you use if else condition in any language, the similar things will create some conditions. The feedback loops are nothing but the conditions. Okay. So if that condition is satisfied, something will happen. If that condition is not satisfied, something will not happen. So that is what internal conditions and rules you are going to create. Okay, I will agree with that. But how many types of feedback you have and what they do in terms of the system? Okay, you have two types of feedbacks. Please remember. One is positive feedback and second is negative feedback. Okay. So this is overall your system. Hope my slide got changed. Am I right? Have you got the new slide?
No, sir, it's still in the self-aware.
Okay, just a minute. I'll change. Are you getting changes in my screen? Maybe I will reshare it. Entire screen I shared. I think now we're fine. Am I right? So is the feedback loops visible? Why this is taking this much time?
Yes, sir, it's visible.
It's visible, eh? Okay. Fine. So feedback loops are the concepts which you need to observe in the system. But how feedback loops actually works is given in this. So this is what your natural or any system which is having the intelligence. Okay, this one. How you are understanding is this macro emergent behavior, that is what you are observing externally. That means that may be a dog, rat, cat, or human being, or any other system. That may be an intelligent robot. What you are observing? You are observing macro emergent behavior. This is what you are seeing actually. But this is always driven by local fitness estimation. This behavior always driven by local fitness estimation. This is what I told. The self-awareness. The self-awareness. It is always changing its structure or form or the functionalities with respect to external conditions. So that means it has to keep monitoring on its own. So that is self-awareness. So now when it is keep monitoring its own structure, form and functions, then those will change according to some local adaptation rules. Who are creating these rules? These rules are already coded in those species. These rules are already there in those species. Maybe nature created. If you are creating your own system, you are going to create. So what they do? These adaptation rules actually tells you which structure is suitable. Based on that variations, you observe the micro emergent behavior. Fine. Now see, this depends on this. Now, this local adaptation rules again depends on micro local execution rules. Okay, micro local execution rules. That means at each individual subsystem, something is happening. Which subsystem has to work? Which subsystem has to trigger immediately? Which subsystem has to work after some time? Who will decide all these things? So that is where you get the micro local execution rules. Okay, these you have to create in your own system. These things will decide how your subsystems will communicate each other and work together. And now these local adaptation rules will depend on these things. These things will carry out the subsystems collaboration, subsystems how they need to work. So that will actually encourage the local adaptation rules, that will actually changes the function form and the structure that will appear as somebody's behavior. Okay, now you see, I'm telling micro level rules and adaptation rules. How a rule come into existence? What is mean by rule? Please try to understand. Rule is nothing but the feedback loop. Because if you find something while monitoring your own system, if you find something is wrong, that feedback should be given to somebody. Whom you are going to give? You are going to give to this. And this feedback, if these adaptation rules need some change in the subsystem, that feedback should be sent to this part, so that subsystems are organized in a particular fashion. These subsystems together again depends on the macro emergent behavior. Now this cycle, if you understand, here whatever you are seeing in the monitor is the system with the intelligent behavior. Here, this red color one, what you are going to see externally, that depends on the system. It is observing on its own. It is awareness, self-local fitness estimation. So whether the system is ready or not, it will keep monitoring. So this will again depends on local adaptation rules. Again, these rules depends on micro rules. Micro rules mostly impact the subsystems. So if you change subsystems in a particular fashion, those subsystems will work in a particular pattern according to the rules, local adaptation rules. According to these, but the particular pattern of subsystems, it will monitor whether they are suitable or not. Then, if it is suitable, that will emerge as a behavior. Okay, so that's the reason why all the intelligence are systems, all the intelligent systems are combination of rules and feedback loops. In order to trigger the rules and in order to trigger the rules, you must create feedback loops. That means feedback must be going from one subsystem to another subsystem, one chunk of one side to another side, one area to another area. So that means if you create feedback loops like this, these will organize whether all conditions are satisfied or not, whether which rule is suitable for particular situation. And in order to create or the execute this rule, what are the micro changes or the subsystem changes should appear? Okay, so that means in any system you take, that may be a device or a that may be a spacecraft, that may be any artificial device, you are trying to build a macro emergent behavior, but you need to do inside self-awareness capability, along with you have to build some rules inside. By using electronics you build them. Okay, you use the software to run those electronics, it's fine, but those rules again supported by micro level rules, which will really impact the subsystem. Okay, so all subsystems together follow a particular pattern according to this rule. So who will tell that which a particular rule to be adopted? This feedback loop. Information coming from this way. So this information flow, if you create as feedback, then particular rules are adopted, then accordingly micro level changes will take place, then that will emerge as a behavior. Hope you understand. Okay, so please remember the feedback loops or the internal conditions you are going to create to trigger some rules is the key to design any kind of intelligent behavior. Okay, now I'm changing my slide. Please let me know whether it is changed or not. Is my slide changed?
Yes, sir.
Now the question comes, sir, okay, sir, we understood that. Now onwards, we need to observe the feedback loops in nature. And those feedback loops we have to create in our systems to make them intelligent. Many feedback loops will come into picture for a single system. Then what are the different kinds of feedbacks and what they are? What is mean by feedback loop? As I told, positive and negative feedback, right? Please remember, if any change is taking place in the system, in that particular case, if any feedback is coming, that feedback is going to increase the change, reinforce the change. Okay, if that feedback is reinforcing the change or increasing the change, then that feedback is called positive feedback. Another name for positive feedback is self-reinforcing feedback. Okay, self-reinforcing feedback. That means that information will make the change to become more and more in your system. That is called positive feedback. Another kind of feedback is negative feedback, self-correcting feedback. That means if some information is exchanged, then that information trigger the system to stop the change, to oppose the change. That means system will try to bring it back to the equilibrium. Okay. Now tell me, you must have got fever. You took a medicine. Then what kind of feedback your medicine is creating inside? You got a fever. You took a medicine. Okay. So what kind of feedback is working in your system after taking the medicine?
The negative feedback.
Why negative?
It brings the equilibrium.
That means the system is already away from the equilibrium, that is called fever. When you take nothing to do with the medicine, actually, I'm not talking about the medicine. So when you take the medicine, The internal system actually triggering a rule to reduce temperature. Okay, that means it is your medicine is actually giving a negative feedback to the body so that internal systems in the body will reduce the temperature and bring back the body to equilibrium. Okay, so those are the two very important feedback loops you must understand to build intelligent systems. Kindly remember, the feedback loops are, because I'm coming in a very systematic manner. First, I told in the nature, you need to consider one inspiration. In that inspiration, you will see self-awareness, self-evolution, and self-improvement. But definitely you will ask a question, sir, these are fine. We will observe them with respect to their functions in the external conditions. But how to build that behavior? How that behavior is occurring? That means you need to go inside the system. Okay. If you go inside the system, I introduced another thing. Inside the system, there are 3 layers of rules. One is system must understand, or system must be aware of its own structure and what are the changes taking place, whether everything is working properly or not. Okay, that awareness is needed. For that, what are needed? You need some rules to check that. So if you have those rules to check them, how that rule is executed, you must have micro level rules which actually deal with subsystems. In that particular case, these are all rules are driven by what? These rules are driven by information exchanges. That information exchange is categorized into 2 types. That is negative feedback and positive feedback. If it is a positive feedback, the system will increase the change. Change is already taking place. If the feedback comes, system will increase the change. If the negative feedback, if the information trigger the negative feedback, means system will oppose the change and try to bring back on its own to the equilibrium. That means medicine is actually triggering negative feedback in your body. That way, if you understand. Okay. Now, I will tell you one more example. When these days automatic cars came, in automatic cars, there is a hill assist. One feature is there. In the hill assist, what happens is when the car identify that it is on the it is on the mountain area, or it is on the hilly area, it is on the slope and climbing. In that particular case, engine speed will increase on its own to move forward in automatic cars especially. Okay, that is what kind of feedback?
Positive feedback.
Why positive?
The change in the engine power increases as the time gradually.
Because power is changing, but feedback came. What kind of information came as feedback? Information is you are actually climbing. The surface is not flat, surface is sloping. This information coming, this information triggering what kind of feedback? Negative feedback, sorry, positive feedback. That means engine speed will increase further to keep the system not to come back. Okay, so this way, negative feedback and positive feedbacks, if you create inside, those will create rules. Those rules actually trigger subsystem coordination. Then according to some macro level rules, those will actually monitor whether all working intact or not. Then these all things actually executed, then you observe the external level behavior. So this is what my answer is. What is happening inside? What is happening inside is the feedback loops triggering different rules. Okay, those are actually triggering different functionalities. Those are appearing or changing with respect to time. That will actually appear as behavior to you externally. Hope you understood. So this is what happening in the system or in the biological system or any intelligent system. Kindly remember feedback loops. Feedback loops are the major things that are triggering rules. Okay, rule for activating some function, rule for activating some operator, rule for reducing some operator, rule for switching off some operator, rule for activating 5 functions at a time. Okay, so these are all rules are triggered by feedback loops. So if you want to build a architecture for intelligent systems, you must know what are the feedback loops you must have inside the system. For better understanding, in software, you use that if and switch statements to create feedback loops. That means conditions. Okay, you are creating conditions. So whatever feedback comes, if the system is enhancing its change, that is the positive feedback. If the system is reducing the change and coming back to equilibrium, that is the negative feedback. Please study on that and try to understand. Okay, so creating feedback loops inside the system is most important to design the intelligence. To design the intelligence. Okay, now if you see, hope my slide changed. Is my slide changed?
No, sir.
Not it.
No, sir. Yeah. Fine.
Yes.
Yeah. So now if you see natural systems like honeybees, okay. So honeybees, if you see, they call waggle dance. The waggle dance has a positive feedback to attract the attention of other entities about foraging at specific location. Okay, so positive feedback means they have to reinforce the change. They will keep changing the form or structure. So that kind of things already exist in nature. Only thing is you have to observe and understand. Okay, so now in the biological immune system, that's a great thing you have in your body. It's a distributed architecture. Am I right? So each cell will work individually. Just its thing is it will pass the information, the neuron. Okay. So there is no central control system. They will work on their own. Okay. They'll pass the information to the brain. So there is no really you can't really control the neuron at my toe. But they do their job. That is what distributed system means. But here what happens is these systems will learn the things over the period of time. Learning means what? If I say learning means creating more and more feedback loops inside or creating fresh feedback loops inside. Will you agree with me? Or creating more rules inside. Is that what learning means? Will you agree with me? There is no other goal. You have to agree. Okay. What is mean by learning is nothing but inside the system, the feedback loops are refreshed or enhanced continuously. Sometimes the irrelevant feedback loops are gone. The new suitable feedback loops are formed on their own. So over the period of time, my body is building the rules on its own. That means feedback loops also changing on their own. So that is what I mean by learning. That is actually triggers the evolution, improvement, and awareness. Okay, so that's the reason why feedback loops, if they continuously change, continuously in the sense as per the demand, as per the external requirements. If new feedback loops are created, that means system is evolving. Okay, system is evolving. Suppose on the day one, if you create 100 feedback loops, after 100 days also 100 feedback loops, same loops are there with the same conditions, then system is not evolving, system is static. Suppose after 100 days you see 100 feedback loops, but rules are changed. Only 100 feedback loops or circuit loops are there, but the feedback loop pattern or the rules are changed. That means feedback loops are refreshed. So feedback loops are changing with respect to external requirement. If though that is happening, then system is said to be evolving. Then you can call it as learning. Okay, this learning concept will come in your artificial neural networks. Okay, learning means there are a number of feedback loops, but over the period of time, by the interaction with the environment, by the interaction with the other systems, your system continuously changing or refreshing or increasing number of feedback loops inside. So if the feedback loops also changes, rules also changes. When rules also changing, then the behavior, functionalities, everything is changing. So that is what I mean by learning. Okay. So that is what you need to understand in nature or the systems with some intelligence. With that, you know what is the definition, you know what are the different levels, you know what are the different dimensions of intelligence, you know where to look at the intelligence. In nature, you can look, many systems are there. Metaphorically, how to understand the intelligence in those systems, that is amplification and equilibrium. Okay, now you know, okay, amplification and equilibrium are happening. What I really need to learn in that particular system, what you need to learn or understand it is feedback loops. So you understood almost about the intelligence. If you really get the feedback loops, what are the feedback loops happening? For this, you need not to kill the dog or the donkey. Okay, but you need to understand them. What rules can trigger these functions? Inside rules, not external conditions. Okay, if these feedback loops are changing with respect to time, that may be increasing, getting refreshed, or changing. Okay, so sometimes at the initial stage, for a particular rule, there is a positive feedback, Then after some time, if you see the same rule has a negative feedback, that means that is needed for the system. That's why system changed on its own. Okay. So if you understand feedback loops, you will understand what are the rules inside that those triggering the functions. If you understand the functions, the variation of functions will appear as behavior which you can observe externally. That behavior you can actually understand with respect to equilibrium and amplification. Then this intelligence you can code into 6 different dimensions and 7 different levels. That is what overall intelligence means. Okay. Now, before going to the other, I would like to give the assignment. This assignment you have to take it very seriously. You have to do it. Now you did the last 2-3 weeks you are doing on the smart dining table. Okay. So in the smart dining table, tell me how many feedback loops you can observe. That means for in the hotel, you are using robotic dining table plus chairs. When you are using robotic dining table plus chairs, so those are all together I called as troop. Okay. Then inspired by feedback loops in the immune system. Okay. So immune system, leave it. You just tell me, okay, if you get inspiration from the immune system also, I'm okay with that. But in immune system, here I gave 3 points. Please remember. Biological immune system can be seen as massively distributed architecture with a diverse set of cells distributed throughout the body but communicating using chemical signals. So one neuron is communicating with the other neurons. Here, one table should be communicating with the other tables and table should be communicating with the chairs. Okay. There is no central control. The multitude of independent cells work together, resulting in the emergent behavior of immune system. Okay. That is known already. There is no central control. They work on their own, learning. Okay. Now, the immune system evolved to adapt and improve the overall system performance. These are about the immune system. Suppose if I ask you, I will just give some robotic dining tables and chairs in the hotel and I don't appoint anyone. Okay. Then please kindly define the behavior similar to immune system which helps the hotel to organize. That means you already understood what are all the things happening in the hotel. Customers are coming, they are sitting in the different places, they are chatting, they are actually interacting with the servers, they have to interact with the different places. So they have to sit for some time, they have to eat and comfortably they have to sit, then they have to go out. For all these things, can you design a behavior inspired by the immune system? What is your inspiration? The immune system of human body. What you need to create? The robotic dining table. Okay. So please do that. But we will discuss in the next class the same concept. Okay. Because we need 2 classes to complete things. So I request everyone, please do things. So your inspiration is immune system. You may study on that for next 2 hours, no problem. And observe what are the feedback loops. Okay. So how many positive feedback loops and how many negative feedback loops you can find in the immune system. And those can you apply in the dining table concept in the hotel. So what are the conditions you are applying? Conditions are a hotel with a cash counter, where customers are coming. They have to sit, they have to eat, they have to talk, then they have to communicate with the server, and they have to wash their hands. So this environment you are creating. In that environment, whether this robotic dining table troop, that means they are working all together like immune system. What kind of behavior you actually expect from this robotic dining table troop? Okay, point number one. Second, in order to create that, what are the feedback loops or information flows you are going to create there? How to create? You can use electronics plus coding. That is the only way we have. Okay, you can use electronic circuits plus coding. That is fine, you can create. But what are the information feedback loops? How many positive feedback and how many negative feedback you need to create in those robotic dining table troop to design a behavior for hotel? Okay, so you can read about immune system, understand it, then apply on robotic dining table troop. So that is what about the assignment. Hope you understand. So what I do is, so I will try to stop the presentation, stop the recording. Then that video will be there in